Our next lesson in Module 7, Lesson 3 is going to be 7.3, Distributing with Rational Numbers. So our goal for this lesson is to learn to eliminate decimals and fractions prior to distribution in order to solve equations. Now with this Module 7, Lesson 3, I'm actually going to be going through this lesson in 3 videos, so there will be another part coming up tomorrow. But for today, we're just going to look at several examples of how we can get rid of decimals and how we can get rid of fractions and then distribute in order to solve our equations. So it's taking what we learned yesterday in 7.3a and combining it a little bit with what we learned in 7.3 or 7.2 in order to solve our equations. And so I want to start off our video with a couple pieces of notes to help kind of guide our thinking as we're going through and solving these problems. That will have either fractions or decimals outside of the grouping symbols that we're going to be dealing with, and will help us determine the best course of action for eliminating those fractions or those decimals. And it really all depends on the type of problem that you find yourself dealing with. So let's go ahead and take a look at a couple different cases and see how we can go about solving these problems in order to first eliminate the fractions and decimals in order to solve the equation. So our first note that we have says this: for most problems that have fractions to distribute, so we've been going over distribution, we did that in 7.3a, the numbers that we've been distributing so far have been whole numbers. Okay, but if there was a fraction that you were supposed to distribute, we should eliminate the fractions by multiplying the equation by the least common multiple of the denominators. For some reason, my HRW refers to them as LCD, and I don't know what that stands for, but we're going to use LCM for least common multiple. So we want to multiply the equation by the least common multiple of the denominators. We did that back in 7.2. The resulting computations will be less complicated without fractions. So the whole idea is to work to eliminate the fractions. Now using this method will work for every single problem that has a fraction that we're supposed to distribute. If there's a fraction out front, we can multiply by the least common multiple of the denominators to eliminate the fractions, and we'll be left with nice whole integers in order to solve our equation, and we won't have to deal with fractions or anything like that. We do have kind of a special case, however, depending on what the numbers that we're distributing to might look like. Alright, and so here is our special case. If distributing the fraction will result in whole number coefficients and constants, then you do not need to multiply by the least common multiple first. Now, let me show you an example of what that's going to look like. Alright, so here's our example. We have the equation 2/3 times the quantity x minus 15 is equal to 5/2 times the quantity 8x plus 14. Here is how you can know if you're dealing with a special case. We want to again focus on the denominators. So we have a 3 here on the left and a 2 here on the right for our denominators. We look at our denominator, which again is 3, and we look at the numbers that we have inside our parentheses. The thing about these numbers inside these parentheses is 6 and 15 are both multiples of 3. They're both multiples of 3. So we can multiply a whole number by 3 to get the numbers that we have inside our parentheses. On the right side, our denominator is 2. Again, looking at our numbers inside the parentheses, 8 is a multiple of 2, and 14 is a multiple of 2. So when the terms inside the parentheses are multiples of your denominator, then you don't need to multiply the entire equation by the LCM first. You can go ahead and distribute, and when you distribute, the numbers inside the parentheses will cancel with the denominator, and you'll be left with whole numbers. Let's go ahead and finish this example, or at least take the next step, so we can see what I'm talking about here. Let's focus on the left side. We're going to take our 2/3, and we're going to distribute it to 6x and to minus 15. 2/3 multiplied by 6x. I'm going to put this 6x over 1 just so that I can recognize it as a fraction. 3 goes into 3 once. 3 goes into 6 2 times. Now I multiply my numerator, so 2 times 2 gives me 4, over 1 times 1 is 1, giving me 4 over 1x. Now I don't need to leave that as over 1. It doesn't hurt me to do so, but I don't need to leave it as over 1. So in my next step, I'm going to eliminate that denominator because, again, a denominator of 1 doesn't help our fraction out at all. Next step, I'm going to bring down the minus sign, and then I'm going to distribute 2/3 into 15. Now 3 goes into 3 once. I have that already here. 3 goes into 3 once. And 3 also goes into 15 5 times. Now I multiply numerator by numerator. 2 times 5 gives me 10. Or I could write it as 10 over 1. Bring down my equal sign. Next I'm moving over to the right side. 5 halves, I'm going to distribute that into the parentheses here. So I'm going to distribute 5 halves to 8x. I'm going to put this over 1 again. Now 2 goes into 2 once. 2 goes into 8 4 times. Now I multiply the numerators and I get 20. Denominators multiplied get me 1. Bring down my x. Bring down my plus sign. And now I'm going to multiply my 5 halves times 14. Again, 2 goes into 2 once. I did that right here. And 2 goes into 14 7 times. 5 times 7 gives me 35. I can write that as 35 over 1. And now we see that I have all of my fractions over 1. I don't need to have over 1 as my denominator. So I can go ahead and eliminate all the denominators. And so when I do that, I end up with 4x minus 10 is equal to 20x plus 35. In my opinion, if you recognize that you can use this special case criteria, do so. It will save you some time and effort. But if you don't recognize that a problem that you're working on is in fact a special case, it's okay to use the other method in order to solve the equation. So let's take a look at a few more examples and see how we can eliminate fractions and how we can eliminate decimals in order to make distribution easier and then therefore solve our equations. Alright, so for our second example, we have 2/3 times the quantity n minus 6 is equal to 5n minus 43. Now this is not a special case because if we were to distribute this 2/3 into this n minus 6, then we would still end up with a fraction. But if we had a coefficient in front of this n that was a multiple of 3, let's say it was 6, 9, 12, 15, 18, something like that for a coefficient in front of the n, then it would be the special case because we would have a multiple of 3 as our coefficient here and a multiple of 3 as our constant term here. However, because we don't have a multiple of 3 as our coefficient, this is not a special case. So we do not want to start this problem by using distribution. That's not what we want to do here. Instead, what we want to do is we want to eliminate this fraction. It's nice that there's only one fraction in this example, and we want to eliminate that one fraction. Now, in 7.3a, I talked about some different grouping symbols, and here we have our parentheses as our first set of grouping symbols. Now, if we're going to go ahead and multiply by the entire equation, we're not going to use another set of parentheses like this. That's not what we're going to do. Instead, we're going to go ahead and use our second type of grouping symbols, which are our brackets. Okay? Now, in order to eliminate that 2/3, we want to multiply by the least common multiple of our denominator. And since there's only one fraction, our least common multiple is the actual value of the denominator. So we're going to multiply the entire thing by 3. Now here's what happens when we distribute that 3 to the left side of our equal sign, when we distribute our 3 over here. It is actually going to cancel with the denominator right away. So this 3 and that 3 are going to cancel. We do not take this 3 into the n minus 6. That is not what we want to do. When we distribute into something that's already being distributed, we just multiply the numbers that we're using for our distribution. So we have 3 over 1 times 2 over 3. The 3's cancel, and we're left with the 2 out front. So we have 2 times n minus 6. Bring down our equal sign. However, we don't just distribute this 3 over 1 on the left side. We have to distribute it to the right side as well. And now notice that we have this grouping symbol here. So we have to almost imagine that we're putting another grouping symbol here. So we're going to have 3 grouping symbol 5n minus 43. We've eliminated our fractions. We still have some distribution to do, but we have gotten rid of our fraction, and now this problem is going to be much easier to solve. Let me just go back over one more time what I did on the right side there. I knew I had to multiply the entire equation by 3 because I had this denominator of 3. So when I took this 3 and distributed it to the right side over here, I had to envision that I was putting grouping symbols around this 5n minus 43. Or what we could have done is we could have distributed to the 5n and to the minus 43. It's the same thing as what we're going to get for our next step. So whichever method you prefer, feel free to go ahead with that route. At this point, we're going to do our distribution. We're going to distribute 2 on the left and 3 on the right. So we have 2 times n gives us 2n. Bring down the minus sign, and then 2 times 6 gives us 12. Bring down our equal sign. Now I'm going to distribute 3 into 5n. Gives me 15n. And 3 to 43, should have brought down my negative sign first. 3 times 43 is going to give us a 129. Now don't let that negative 129 scare you. This is a problem exactly like what we did in lesson 7.1. We can go ahead and finish it up just to show that we're able to do these types of problems. My next step, I look at my coefficients. 2 over here, 15 over here. 2 is less than 15, so I'm going to start by removing or eliminating this 2n from the left. And again, the reason that I choose to start on the left side is because this 2 is smaller than 15. If 15 was over here and 2 was over here, I would still eliminate the 2. It doesn't matter which side of the equal sign you're on. What matters is which coefficient is less than the other coefficient. So to take our next step, subtract 2n from both sides. These cancel. Do not forget about this minus sign here. This minus sign is connected with the 12. We need to make sure that we bring that down with our 12. Bring down our equal sign and keep those all aligned. Now, 15n minus 2n is going to give me 13n minus 129. My variable term is on the right. I don't have a variable term on the left. The only thing I have on the left is my constant term, so that means I want to take this constant term on the right and move it over to the left. To do that, I want to add 129 to both sides. These will cancel on the right side, and on the left side I'm going to take negative 12 plus 129 to give me 117. So I have 117 on the left side. Bring down my equal sign, make sure that I keep those aligned. On the right side, I'm going to bring down my 13n. My last step is going to be to divide by the coefficient. So I divide both sides by 13, and I'm going to get n is equal to 9. n is equal to 9. So a lot of work went into this problem. We can see that there were a lot of steps that we had to take in order to solve it. But if you just take it one step at a time, don't get overwhelmed by how complicated or messy the equation might look. Just take one step at a time. Start with distribution. Then if there's any like terms you can combine, do that. Then you're just using inverse operations to move things around the equal sign, and then finally solve. So let's take a look at a couple more examples. We're probably not going to run through the entire example for the next few, just showing how we can eliminate the fractions or the decimals. Our next example, we have 1/2 times the quantity 7x minus 4 is equal to 3/5 times the quantity 8x plus 6. Now we have to eliminate this fraction here and this fraction here, and this is not a special case problem because 7 is not a factor of 2, nor is 8 or 6 factors of 5. I'm sorry, not factors, multiples. 7 is not a multiple of 2, 8 and 6 are not multiples of 5. So this is not a special case. We can't just distribute our fractions and expect our numbers to be all integers. So we have to eliminate the fractions on both sides. What that means is we have to find the least common multiple of 2 and of 5 in order to eliminate these fractions. So multiples of 2, 2, 4, 6, 8, 10, 12. Multiples of 5, 5, 10, 15, 20. Of those numbers I just listed, 10 was a common multiple that they both had. It's the least common multiple. So what that means is we're going to multiply our entire equation by 10, or we can think of it as 10 over 1. And when we take this 10 and distribute it on the left side, we're not distributing it to our parentheses. We're only distributing it to the number out front because all of this is getting multiplied together. If there was an extra term, let's say I had like a plus 7 over here or something like that, then I would also need to distribute my 10 to the plus 7. But that's not the case for this problem, so I don't need to worry about it. So we'll undo all that. Now, when we simplify or distribute our fractions, we remember that 2 goes into 2 once, 2 goes into 10 5 times. So now I have 5 times 1 gives me 5. So I have 5 times the quantity 7x minus 4. Bring down my equal sign. Going over that one more time, I had this 2 in my denominator of this fraction, 10 in my numerator of this fraction, so I'm doing some canceling. 2 is my factor for 2 and 10, so 2 goes into 2 once, 2 goes into 10 5 times. So now I have this 5 times this 1 gives me this 5. All right, going back, and now I'm going to distribute on the right side. So I rewrote my fraction out front. You guys don't have to do that. I just wanted to make it a little clearer what I'm doing. I'm taking this 10, distributing it to my 3/5. It does not also get distributed to my 8x plus 6 because they're all getting multiplied together. When I distribute, or when I multiply my 10 over 1 times my 3 over 5, 5 goes into 5 once, 5 goes into 10 twice. So now I'm going to take my 2 and my 3 and multiply those together. 2 times 3 gives me 6. Then I just copy down the rest of the equation. Okay? So that's all I'm doing in getting rid of my fractions is I'm multiplying both sides by the least common multiple, just like what we did back in 7.2. Let's take it one step further, and then we'll stop there. Our next step says we need to distribute. So I'm going to take my terms out front, my 5 and my 6, and I'm going to distribute them to everything inside the parentheses. So 5 times 7x gives me 35x. Bring down my minus sign. 5 times 4 gives me 20. Bring down my equal sign, doing my best to keep those aligned. On the right side, 6 times 8x is going to give me 48x. 6 times 6 is going to give me plus 36. Alright, if you guys want to continue and solve it from there, you may go ahead and do so. I will say that I just made this problem up, so you're probably not going to get a nice, neat answer, but you should still be able to get a value for x. Now, we've looked at 3 examples that involve a fraction that we would have to distribute. Now let's take a look at 2 examples where we have a decimal or decimals that we might have to distribute. Example 4, we have 1.2 times the quantity negative 9x plus 4 is equal to negative 7.3 times the quantity x minus 8. We're going to go about getting rid of our decimals in this equation the exact same way that we did this, got rid of the decimals back in 7.2b. We're going to put grouping symbols around our entire equation, and then we're going to multiply by whatever place value our decimals terminate in. Here, our decimal terminates in the tenths place, and here our decimal also terminates in the tenths place. Therefore, I'm going to multiply my entire equation by 10. So multiplying the entire equation by 10, I'm going to distribute this 10 to this 1.2. I am not going to distribute it to the negative 9x plus 4. I only distribute it to the number out front. Then I'm also going to distribute it to the negative 7.3, but I'm not going to distribute it to the x minus 8. So when I multiply 10 times 1.2, I'm going to get 12. Bring down my negative 9x plus 4. Close parentheses, equal sign. And now on the right side, bring down my negative. 7.3 times 10 is going to give me 73 times the quantity x minus 8. Alright, and if you want to continue this problem again on your own, feel free. I made this problem up. You're probably not going to get a neat answer, but you can solve this problem for x. Let's go ahead and take a look at just one more example. Final example, we have 3.14 times the quantity negative x plus 1, and that's equal to 6.08 times the quantity 2x plus 7. We know that this is an approximation of pi, and we know that pi is an irrational number that goes on forever. This, however, is not an irrational number. We have to think of it as just 3.14. We ask ourselves, what decimal place does this number terminate? It terminates in the hundredths place. Likewise, on the right side, what decimal place does this number terminate at? Terminates again in the hundredths place. So we use our grouping symbol to show that we're going to be multiplying, in this case by 100, because our decimals both terminate in the hundredths place. Let's say that this was our problem instead. We have 3.1 instead of 3.14. Now this number terminates in the tenths place, but this number over here still terminates in the hundredths place. Because this number terminates further from the decimal, this is the place value that we're going to multiply both sides by. Okay, let's go back to having 3.14 and multiplying everything by 100. Still multiplying just the numbers out front. So 100 times 3.14 is going to give us 314 times the quantity negative x plus 1. And that's equal to, on the right side, 100 times 6.08 is going to give us 608 times 2x plus 7. Now, multiplying by 314 and multiplying by 608, not something that sounds fun to do, but we can do that multiplication. And I would expect you guys to be able to do that and show all your work for multiplying by 314 and multiplying by 608. Alright? Again, I'm not going to finish the problem here because I just wanted to show us how we can eliminate the decimals from these equations. Now that we've gone through these 5 examples, I hope that you're able to eliminate decimals and fractions prior to distribution in order to solve equations. Write down any questions or comments or concerns that you might have regarding this lesson, and we will go through it tomorrow or our next day in class.